Okay, question number 10. What is the stacking sequence of FCC and HCP? So these two structures are the only close pack structures. And they have the same atomic packing factor. And we are going to calculate them here. So let us start with the stacking sequences. For FCC, the stacking sequence is ABC, ABC in 3 dimensions. For HCP, it's going to be AB, AB. As for the packing factors, the atomic packing factor for any given crystal structure is calculated as volume occupied by the atom times the number of atoms in the unit cell divided by volume of the unit cell. Now for FCC, the calculation is going to be very straightforward. The V unit cell is A cubed. What is A here? If you draw the FCC structure again, they touch on the face diagonal. A square root 2 is 4r. VUC is going to be 2 square root 2 r squared. Now, how many atoms are included in this face-centered cubic? 8 corner atoms, 1/8 of them, plus 6 face atoms, half of them, in total 4 atoms. Now, atomic packing factor, 4/3 pi r cubed times 4 atoms divided by, what is the volume of the unit cell? This is cubed, 2 square root 2 r cubed. 2 cubed is 8, square root 2 cubed is 2 square root 2. So 8 times 2 square root 2 r cubed. If you simplify this expression, you will get 16 pi r cubed divided by 3 divided by 16 square root 2 r cubed. R cubed terms cancel out. 16 cancels out. You will get pi divided by 3 square root 2, which is approximately 0.74, which is the result that we expect for FCC. So for HCP, since we know that both of their atomic packing factors are the same, we expect the same value. Now, HCP is a little bit complicated structure. Okay, I will directly show it from here. So you draw the basal planes first. The basal planes are hexagons, hence the name hexagonal close packed. Okay, in the hexagonal close packed structure, there are 6 corner atoms here. 6 corner atoms at the bottom, 1 face atom at the top, 1 face atom at the bottom, and the remaining 3 atoms sit inside the unit cell itself. That's why it has AB packing. So the top and bottom packing is the same, but the middle packing is different. It's 3 atoms sitting on top of each other. So if you calculate the number of atoms inside the HCP, okay, so we have 3 atoms sitting inside the unit cell. 1/2 of the center of the face atom, center of the basal plane, plus 6 corner atoms, and there are 2 of them. So in total you will have 6 atoms. Now the complicated bit is calculating this V unit cell. Now volume for any given unit cell is going to be area of the basal plane times the height, which is denoted as C for hexagonal close packed. This is A. For hexagonal close packed structures, let's draw the basal plane first. Sorry. It's a hexagon, regular hexagon, and the corner atoms are touching each other as well as the center atom. So all the atoms in the basal plane are touching each other. This is supposed to be a corner here. So we can directly observe that edge of the unit cell A here, and it's A everywhere, regular hexagon, is going to be 2R. Now in the question, the C over A ratio is already given to us. You can actually prove this by pure geometry, assuming the closed-packed structure is ideal, etc. The C over A ratio turns out to be, from the 3D geometry, square root of 8 over 3, which approximately turns around to be 1.633. So if A is 2R, then C is equal to 1.633 times 2R. Now, we know the height, then we need to calculate the area of the basal plane here. Now, a regular hexagon is made up of, that's a really bad drawing, let me draw it again. So imagine this as a regular hexagon. Then there are 3 equilateral triangles, 6 equilateral triangles, and each of them has the same area. So if this is edge A squared square root 3 divided by 4 is area of the one equilateral triangle, and there are 6 of them. And we know that A is 2R. So if you substitute those expressions here, and so atomic packing factor is going to be, as we calculated, we have 6 atoms times 4 over 3 pi r cubed divided by, we know C, 1.633 times 2R. We know the area, 6 times 2R squared, square root 3 divided by 4. If you simplify this expression, the r cubes will cancel each other, and you will get 8 pi divided by 1.633 times 2 times 6 square root 3. If you evaluate that, the atomic packing factor for HCP is again approximately 0.74. As we expect, FCC and HCP has the same atomic packing factor.